Yeah, thank you very much, Nishant, and thanks to all the people available online. It's a privilege, I would say, to be making this particular presentation online, which is pretty close to my heart because most of the work in India, what we have done as part of ISRO's activity, has been to see to that we take the applications to the people in the country. So I will be sharing with you certain typical examples, actually working examples, which are functional even today for the country. Uh, Basically, when we look at the space program in India, we look at the space segment, we look at the institutional linkages and also the various elements related to the data segment. And ultimately, all of them are linked to the space applications. Again, when we look at the space applications, the specific things are with respect to the land, water, ocean, and atmosphere. And we have a very clear focus on our space program in such a way that all these satellites, what we launch, have a clear focus on these elements. That's how the whole the program of Earth observation system has been organized and the way it is functioning today. And we have set up a solid example in bringing the applications to the people of the country. And that's what this particular slide tries to highlight. When we look at the various the launches that we have done, various satellites that we have launched with respect to the Earth observation satellites, as well as the meteorological satellites. The focus again has been to see to that the data that we get from space gets pretty well calibrated with respect to the ground measurements. So when we have a space launch, we always see to that we have sufficiently good number of instruments on the ground so that we are able to do a very clear, accurate calibration of the data what we get from space, and we are able to ultimately get at the exact information that we are derived from space. So we have been looking at different ways. On the right hand side of your screen, you are able to see some of the typical examples of the ground infrastructure, while at the same time in the middle I'm trying to highlight to you the kind of sensors and the kind of instruments that we have been able to organize at the space segment. Typically, these are the kind of images what we are able to generate from space, be it very simply processed fusion images that provides very high resolution multispectral imaging. At the same time, we are able to generate excellent two-dimensional as well as stereo images that provides highly calibrated, excellent quality data that helps us in deriving the various parameters that we need for varieties of space applications that we aim for. Basically, when we look at the geospatial data usage, we normally look at uh, the way we try to use it on the ground also. For example, there are some very simple concepts we have tried to adopt, wherein not only that the geospatial data coming from space, we try to integrate that with Internet of Things as well as drone data. And even mobiles have been serving a lot of interesting field data provisions. So this helps us in some kind of a multi-platform based system that enables us to utilize all these platforms to ensure that we have accurate data made available, and hence the information derived from these sets of multiple platform data allows us to provide the kind of decisions that the decisions and decision makers and the planners have to really utilize. The other important area in which the space data has been very effectively utilized in India is for the governance. Especially for the last decade, the ministries at the central government have been utilizing the space data in multiple decision-making principles, and they are able to literally implement many of the programs, be it land, water, rural development, urban development. All these major national development programs go through these set of uh, typical space-based implementation systems. When we look at the good governance principles, we always look at the accountability and transparency. That means the public money, the way it gets utilized, it has to be accounted for, and we are able to provide that kind of a proof from space. And again, the good governance also looks at the equitability and inclusiveness. We also look at how effectively the money is spent so that people get the kind of satisfaction what they are looking for. Various policies in the government also is driven particularly with respect to the e-governance in place, how the technology gets integrated with respect to the e-governance, and how we take ultimately the decisions down to the ground. Of course, there is a lot of technology that is being used, especially when we look at the geoprocessing, the Boolean algebra, the way we bring in with the geospatial technology, object tracking systems, or shortest path methods for various applications, including the AI-based tools and technologies. Some of the typical areas I thought I'll just highlight to you is that the agriculture, water, forest, and ocean, these four sectors, we have a very well institutionalized mechanism by which the central government at the highest level takes the decision from the government's point of view. For example, if you talk about agriculture, the major food grains in the country, we are able to provide the acreage and production information 1 month before the harvest. That helps the government in taking the decision with respect to the food security of the country. Similarly, the water, we have at the national level, water resources information system, which basically talks about the surface as well as the groundwater, and it takes into account all the information that is available from space and the ground to ensure that water as an important security is provided to the country. In the forest sector, we have every 2 years the state of forest maps prepared, and the entire monitoring and monitoring mechanism utilizes this space. And of course, we have very dedicated satellites for looking at ocean and ocean productivity, and we have a very good system established under the Ministry of Earth Sciences, which utilizes this. I can go on and on with various kinds of applications that we derive. It could be rural development, urban development, land resources development, disaster management system, wherein the six major sectors of flood, cyclone, landslides, forest fires, earthquakes, and drought get into specifics of using the space data for management as well as mitigation. There are a lot of governance based applications that have been developed over a period of time where we look at soil health card, particularly from the agricultural point of view or farmers information point of view, so that the kind of agriculture that is practiced by the farmers gets information with respect to the NPK availability and even the micronutrients availability. If there are deficiencies, the agricultural experts look at the soil card and then give them the right kind of recommendations. Similarly, there are many other applications. I have just listed out a few, but there are many other applications that we do. It could be housing, it could be rural employment related aspects, it could be decentralized planning, it could be education and health, it could be health, and many other areas. We have brought in the governance principles using the space, and in between we have the drones as well as the mobile applications, which gets integrated as one system to provide the solutions that is required. One typical example which I can highlight is we have been able to map the entire biodiversity that exists in the country by using space and ground methods. It's not just space only. It was a big mission which we have launched, and we have fairly a good grip on the rare and endangered species, those species that need to be conserved, as well as the kind of species that demands very specific conservation measures have been well identified, and we have two very important parameters. One is called as the biological richness, other one is the disturbance regime, which we have been able to clearly bring out. What you're seeing there is actually on the landscape map on the left hand side. In the middle is the Himalayan range, where we are able to get the landscape and we are able to integrate the biological richness data into it. So this is a very good database that allows the forest department as well as the Department of Biotechnology to take a close look at the biodiversity in the country and conserve it and preserve it for a long duration, a long time. On the other side, we have some very interesting rural development program where we are able to literally geotag all the applications that are done on the ground, both from space data as well as from GPS based monitoring mechanism, wherein the money is spent for developing specific infrastructure like check dams, nalabunds, and various other water conservation measures on the ground. But these get pretty well geotagged, as well as we get the data from space to do a cross check, because a huge amount of public money goes into these systems, and we are able to do tracking in the prior stage, during the implementation, as well as the activity is over. We are able to see these assets that are being created. In fact, today, as of today, we are able to easily account for more than 4 crore assets that have been created, which basically enhances the agricultural productivity in the country. India, of course, has been giving a lot of stress on housing for all program, particularly looking at the rural development people where the economic conditions are not so good. So the government has this program, and we are able to monitor the house building program for lakhs of people, wherein at different stages of the house building, we are able to track that out from GPS based mobile trackers, as well as from space data on a routine cross check mechanism. As I was telling, India has a water resources information system, which is a mammoth system, I would say, because it's a very huge database. It's a huge stack of data, what we have, which talks about both surface and groundwater. In addition to that, we have all the important parameters that is required for us to track the water, like it could be hydromet conditions, it could be water quality, it could be snow cover, glacier, inland waterways. You name any water related aspect, we have been able to cover it both from ground and space, and it's an integrated stack of database that we are able to utilize it at all levels, maybe even down to the micro watershed level, where you would like to do a small amount of farming related activity. So the country, as well as the water resources department, uses this data for varieties of applications on the ground. In fact, this is a typical example of how India has water resources information system. At the same time, even the states have developed very interesting water resources information system. For Telangana state, for example, I'm just showing you one example on the right hand side, where all the tanks, all the irrigation tanks, something like 13,700 of them, have been geotagged, and every tank is monitored with respect to the agriculture related activities, both in the post monsoon as well as in the pre monsoon conditions, so that optimal cropping can be done in given conditions, as well as with respect to the season. On the potential fishing zones, this is yet another very important activity, because India has a large coastline, both the western side as well as the eastern side, and we have been able to come out with potential fishing zone mapping system, where we use the chlorophyll data as well as the sea surface temperature information to provide absolutely accurate information with respect to the fish catch. And this particular information is used by the fishermen in the coastal area. And we have also recently come out with a mobile app which uses Navic device. And because of the use of Navic, the fishermen can go deep into the ocean, maybe even 100 kilometers. They are they are taken care safely, because all the information that is provided or required for them is provided to them for their safety, and they can get the best information with respect to fish catch, and they can come back safely with a huge bounty of fish catch. So this is being utilized in all the coastal states of the country, and the app is also pretty effectively utilized by all these people. We have an excellent mapping done for the potential of energy in the country. Especially the focus has been on the non-renewable energy, like the sun, the solar, the wind, and the waves database have been added into the various other forms of energy generation. So energy is a very important sector as far as India is concerned, and we have a very interesting mobile-based calculator that is available, which is provided to all the individuals who would like to exploit the energy on the rooftops. And they do utilize this particular data, so that accurate information with respect to the total amount of energy that they can extract using our INSAT system. We are able to provide this data, and many individuals also use this particular data for exploitation of energy. From the mobile as well as from the GPS, we are able to use the accelerometer that is available in the mobile to find out regular information with respect to the condition of the roads. So we have done excellent experiments in the state of Haryana and Maharashtra, which they have started utilizing, and we are able to draw out maps. These maps will provide very clear information to the decision makers, which are those roads bad, which are those roads good and not so good. So immediate actions are taken as part of the monitoring mechanism, and the roads are set right. So accelerometer and GPS comes into play here when we start utilizing it for the road related data. Um, of course, this is the example of Haryana. Similarly, on the rural development front, watershed development is a major program which we have been very effectively doing it in the country, wherein the slopes and gradients are taken into consideration, and the farmers are taught about it, how to go about doing it, and the entire integrated watershed development program is carried out in such a way that we get excellent produce. The left-hand side image is a very badly affected gully terrains, as you see it on the left hand side, and the whole thing on the right hand side through a false color composite, you are able to see excellent developments that has taken place. So a period of about 5 years makes the entire transformation of a particular system when you start utilizing space-based data for such development. Looking at the success we had by implementing such programs in the state of Karnataka, now the country has taken it up in the entire national level, where today from space we are able to monitor and manage 86,000 micro watersheds across the country, which helps in soil and water conservation for the country in a big way. This is a typical example of before after kind of a situation where you are able to see tremendous amount of vegetation that is coming up because of the conservation measures which has been taken up in a span of about 6-7 years. Similarly, the exact location where you can get the water pond, and here you see the water pond which is able to store a good amount of water. Basically, we look at the slopes. We use the stereo images from space to find out the exact location where to go for farm ponds, and farmers are able to get rich benefits because they are able to get a farm pond, and once they have a farm pond, they are able to go for very good amount of cropping in the neighborhoods. This is an example for urban, where we are able to do urban sprawl monitoring, how the urban sprawl, that means how the urbanization is spreading across about. This is a 50-year animation, what I'm trying to show you here, wherein from 1973 to 2020, we are able to see the dramatic change that has taken place in Bengaluru, one of the fastest growing cities in the world, I would say. So what we did is we were able to map out the population increase, the vehicle increase, the infrastructure increase, and all these things over a period of 50 years. And we are trying to, from this, we are trying to generate a learning curve based on which the future planning can be organized in such a way that it is more systematic in nature and more decent in nature, so that we are able to preserve the natural resources, and at the same time we are able to do the developmental activities. This is a typical analytics what has been done on what is the cost at which such kind of an urbanization has been done. Is it possible for us to do alternative methods so that we can optimize the land use in the way we would like to do? For this, we are adopting newer methods, which we call it as digital twins. We are trying to generate digital twins of cities so that we are able to address those infrastructures in a meaningful way. Basically, what we are trying to do is we are trying to create a virtual object, and a physical object exists. We are able to take the problems on the virtual object, solve the problem on the virtual object, and take it down onto the physical object and try to put it to use. So here we are bringing in the 3D city models in a big way, and very high resolution mapping from space, and we integrate it in such a way through the digital twin mechanism that we are able to sort of understand the problem virtually on a computer, and we are able to simulate the same or emulate the same on the ground and solve those problems on the ground. I don't know if I'm losing out on time. I would like to stop at this, even though I have a few slides, but I wouldn't like to go further. I would like to stop at this point, but you can guide me. If you think I can take another 2 minutes, I can continue, but otherwise it would be good
I
to
think you
have
can go
discussion.
for another 2 minutes. That's fine. Completely.
Is that
Thank you.
okay?
Yeah,
Okay,
yeah,
okay,
yeah.
good, good, good. Thank you, thank you. So the digital twin basically calls for using a lot of sensors on the ground, which helps us in understanding the basic behavior of the mankind. At the same time, the 3D city models allows us to integrate the uh, the IoT devices information that we get from, and we are able to sort of come out with mechanisms which helps us to improve the urban living conditions. The other major area which from the geo analytics which we have been very closely addressing is the disaster management system. Um, in fact, we have been tracking from 2013 onwards. Every year, India faces major problems either in floods or in cyclone or in landslides and things like that. And we have been watching this very closely, and we are trying to find out reasons for it. Obviously, with the climate change setting in a big way, it's difficult for you to control these disasters, but we have to sort of adapt ourselves. So adaptation is the main principle which we are addressing. For example, we have tracked the kind of burning that is going on with respect to the forest fires, and how the forest fires are affecting, and is it possible to do better fighting of the forest fires using the thermal data that we get from space. So near real time information dissemination to the forest guards and how to address the forest fires on the ground. That is what we are looking at. We are also looking at the transboundary disasters where we have good linkages or understanding with, let us say, neighborhood countries like Nepal and others. If there is a landslide, there could be a huge amount of accumulation of water. And if, for example, if they allow the water to flow off in a big way by doing some blasting here, the huge amount of water which is accumulated here on the backdrop could rush into India and could possibly even create a tsunami. So we work with them very closely using very high resolution data. We are able to see the debris, the quality, the amount of debris or the volume of debris, and we are also able to estimate the volume of water. We do a controlled blast in such a way the water trickles out slowly and releases the problem. So we are able to avert major disasters because we are able to use three-dimensional data in a very meaningful way. We put all these data on a geoportal. Like Bhuvan is one of the geoportals which hosts most of the data what we have, and anybody can see this. It uses wide varieties of services, particularly the web map services and web tile services and feature services, which helps us in disseminating the data from the servers. We have multiple servers which serves the entire country, and this is able to sort of give near real time information to the people, and all the major ministries, not only central as well as state and NGOs, utilize this particular data for various types of problem solving. In fact, Bhuvan has become a very important crowdsourcing mechanism where any issue or any major problem happening on the ground, it could be with respect to field realities, with respect to disasters or watershed monitoring or any other incident reporting, they all come off through a simple mobile app. They click, they make the attributes available to us, and this helps us in acting fast. In fact, NDMA uses this kind of a data very effectively on the ground. Thank you very much for the patient listening. Sorry if I have taken a couple of minutes.
Thank you, Professor Diwakar. It was a great talk, actually. Very interesting to know about all of these use cases. I have two questions to start with. The first one is like you mentioned mobile sensor and GPS fusion for road monitoring, right? So, do you also want to tell us about other use cases, other sectors where such fusion has been used? For example, I can very well see in agriculture, one could use soil sensors alongside satellite imagery. For disaster mitigation, one could use drones alongside satellites. So, what's your experience with that?
I think you already answered my question. In fact, I was about to address the same. There is an interesting application in the country with respect to the soil health card, which I mentioned there. See, for example, soil health card is an important aspect. At the same time, there could be issues with respect to the insurance claims. So that is the time where we use the drones as well as the space data. and integrate the two information to really understand whether the claims are correct, whether the claims are accurate. So this is an operational mechanism which India has established, where we do crop insurance claims using drones as well as space data, and either we pay or disallow the pay. So the insurance companies bank on the real truth that comes out from space. So that's an interesting application that we are using. Similarly, with respect to the urban planning, as I was telling you, with respect to the digital twin utilizes not only multiple sensors on the ground to understand, let us say, the traffic, anything that flows. For example, in Bangalore, uh, there is a huge flow of traffic which chokes, which creates problem. Similarly, water, when there is a heavy downpour, it chokes because it is all the drains are already sort of invaded by people. So these two problems are being solved or being attempted by the government to solve using the combination of drones as well as the IoT devices, in addition to the perspectives from space. There are many examples like pollution. Air pollution, we basically use the aerosol optical depth data which we get from space, and we try to integrate that with the PM 2.5 and PM10 measurements, what we do on the ground, and we integrate and provide. In fact, I didn't cover that as part of my presentation. I have a lot more things I would have covered, but I have just taken a few today. So
Sure.
pollution is another area which we address, multiple sensors in addition to space. Yeah.
Thank you. Thank you. So another question that comes to my mind is like, if there is a public portal where satellite imagery based data is publicly available, for example, many people would like to see what the energy data looks like and work with them. So this is just for general knowledge.
Excellent. In fact, the public portal which I talked about right now was Bhuvan, which gives you a whole lot of data on the natural resources of the country. But when it comes to energy, we did this particular database for Niti Aayog, and Niti Aayog has put it out in its public domain. It has put it out in its portal, and ISRO
Awesome.
also has yet another portal. Possibly, I didn't cover it here, but I can certainly provide the link of that particular portal where it is possible for you to see the energy maps of the country. Yeah, it's possible.
Awesome. Thanks. I don't see other questions here. So I think let's thank Professor Diwakar once again for the great talk. And
Thank you.
over to you, Nishant.
Thank you very much.
Thank you so much for that, Professor Diwakar.